Okay. Apa kaitan dengan lagu?
Tak pasal-pasal kan? Tak pasal-pasal. Okay.
Bagi tahu dalam.
So now we are at the summary of the program. Okay, 2 days program that we have almost completed. So far so good.
Ya.
Okay, so far so good. I hope you have learned. So far so good. I hope you have learned enough for you to practice this FMEA. And again, let me wrap up the program. We summarize the program. Again, this FMEA cannot be done on its own. Okay, you need to do some sort of preparation first before you start going to FMEA. Because without the preparation, people will be questioning. Forget about people's question, but you yourself must realize: have I covered the whole universe? Have I reviewed the whole universe of process input elements? Okay. If you think about the whole universe of the process input elements, if you don't know the method, that's going to be quite impossible for you to cover. But that's why we come up with the process map, Q&E, cause and effect matrix, okay, to help you to review, to evaluate, to cover the whole universe of process elements. Okay, so let's get back to the summary. We have to start with process map, and again I emphasize, I hope you have a permanent process map, you know, in your company. Okay, I mean, beside doing every time you want to solve problems, then you build your process map. It should not be done that way. You should have ready one process map for each process, so that whenever something happens, you can always go back to the process map for your review, for your investigation. Okay, and then from time to time you can add whatever input elements that you encounter based on your daily activities at site. Okay, so first you have to prepare your process map. Again, remember, process map, all you need to do in your process map first is to identify all input elements. Okay, all. The second keyword is identify. You don't judge, you don't evaluate, you don't analyze yet at that process map stage. Okay, at process map stage, all you need to do is just to identify, recognize. You recognize that this thing does happen. You recognize that sometimes, sometimes this kind of thing does happen. Seasonally, kita ada musim durian, musim hujan. Okay. So just recognize first at this process map stage. Okay, things does happen. During the rainy season, during the bonus season. Okay, during the promotion season. Okay. So recognize them first. Just recognize as much as possible. Have a standard template for the whole year through. Don't wait until you need to solve a problem that you only build your process map. Okay. And then the number of input elements in the process map definitely will be huge. Okay. So it's quite impossible for a complete process map to be prepared by a project leader that need to solve one small problem. Right. So it's very practical for the department, for the company, to keep a standard process map for each process manufacturing line. Okay, once you have identified all the input elements, okay, of course the output characteristic as well. Once you have identified them, then you need to evaluate the causal relationship between elements for process number 1 need to be evaluated against output characteristics important for process number 1, number 2, number 3, number 4, number 5, so on and so forth. You need to evaluate the causal relationship against all the output characteristics importance. Okay, never mind if there's no strengths at all, but first you need to evaluate. Okay, you need to evaluate because you have no idea about the real root cause. Again, remember I explained to you about my experience in some other root cause analysis program. When the defect was caused, the defect that was found in process number 3 was created by the byproducts of process number 4. Okay, which is quite difficult to analyze. Okay, because normally it must come from the previous product, but instead it came from the later process. Okay, the later process, because the machine's location is very close, and they managed to identify that because the metal chip that create the defect was only produced in the process number 4. That's how they determine that. Without that kind of a detailed analysis down to the material type, they would not be able to understand from where does this dust came from. So it's not. It's better for you, okay, to have this process map, okay, so that you'll be able to understand and to have the causal relationship analyzed throughout the output processes. Sampai ke belakang-belakang sana. Even though the input elements is from process number 1, but you have to understand, you have to analyze the causal relationship strength against output importance up to process to the end. Okay, till the end. So you can see that cause and effect matrix, okay, the width of the funnel, the width of the funnel neck in the middle of the diagram represent the number of variables. Okay, represent the number of variables. Okay, so of course in the process map, that represent the universe of the process. All variables should be in the process map, and then you start filtering out, you start screening out the possible causes. Okay, using your cause and effect matrix, you are going to evaluate the strength of the causal relationship of the input variable against the characteristics of importance to customer of the output variable. Okay, you're going to score them, you're going to grade them, for example, using grades of 1, 5, and 9. Okay, from there you can screen out the variables. Then by the time you get to the FMEA, okay, you will be left with perhaps maybe 10 input variables for you to further analyze using your FMEA. So that's how we screen out the number of possible causes from universe to cause and effect matrix down to FMEA. At the end of the FMEA, at the beginning of the FMEA, you might be analyzing perhaps only 10 input variables. So when people ask you how do you come down to this 10, then you can always explain that we have analyzed our process map, we have evaluated the relationship of causal relationship of the input variable to the output variable, and finally before we start our FMEA, it left us with 10 possible causes. So that's how we investigate the whole process. Okay? Next, process map. Remember the template? Okay? Congratulations to that group for using the standard template: supplier, input, process, output, and customer. Okay? You have to differentiate between input from different supplier. Okay, the same type of input but comes from different supplier. You have to uniquely differentiate them. Okay, because you're going to do analysis. Okay, you have to differentiate them. Okay, and whatever output that goes back into the next process will be considered as input, input from the previous product, semi-finished input from the previous product. Also remember the four categories. Okay, the four categories that you need to identify the possible input. Okay, number one is the input that is already defined in your procedure. Okay, the planned input. And number two is the byproducts of the processes. Okay, what for example, what are the byproducts? Anybody can recall what are the byproducts?
The grease.
Come again? Heat,
Grease.
noise. Okay, all those things you have to identify. That's why when you do your process map, you have to walk down the process. Okay, you have to use your senses, your vision. You have to be very sharp. Maybe the color had worn out. Okay, the color is still red, but already a little bit pale. It's not as bright as a brand new one. So it means something. Okay, it means something. When a paint wear out or wear down, it means it's somehow it's already it's got hot somehow. Okay, hot and cold, hot and cold, hot and cold, and it totally wear out the color. Okay, so you have to be very sensitive with your senses, your vision, your hearing, auditory, okay, your sniffing skill. Okay, you must be able sharply. You must be able to sniff sharply. Just like yesterday, there was a good example. Something was burning outside. Okay, remember? Okay, you don't just ignore. When you smell or when you see, when you hear something out of the ordinary, especially in your workplace, don't just ignore. Okay, you please ask what is going on. What is going on? Seriously, because yesterday we were lucky because that was the cigarette butt that was burning outside. I can say we were lucky because the system was not so sensitive. Okay, if the system was sensitive, then it must have been raining inside this classroom. Okay, it must have been raining inside the classroom. Okay, byproducts, environment, and another one is semi-finished. Okay, semi-finished. So please explore these four aspects when you want to identify your input variables. Okay, when you want to identify your input variables. Again, I think you're okay with customer, with supplier. Okay. The only point for customer is that beside again, just like what I've explained earlier, beside the guideline by the military standard, you have to be as sensitive as the customer out there. Okay. Nowadays, as you all experience, is the era of social media. Okay. People make money out of our mistakes. So that's why people are so excited to convert our mistake into their content. Okay. Into their social media content. A small mistake for you, a big money for them. They'll be happy to promote your mistake. Okay. Nasi lemak dengan telur goreng saiz SIM card. Nasi lemak tu RM2, RM3, tapi dia punya income daripada TikTok yang viral tu mungkin RM1,000, RM2,000. Okay. That's why they keep viraling this kind of small mistakes. They make thousands. Kalau masuk YouTube, satu dunia tengok, per view maybe 10 cent US, 40 cent US. Imagine YouTubers with 100,000 subscribers. 100,000 subscribers all over the world. One small mistake. Okay, so those guidelines by military standard, you can use them as guideline, but you have to protect your interests as well. Okay, you have to raise your standard. Raise your standard meaning that you don't want even a small mistake. So you are going to improve even on the small mistake. You are going to take action even on small defects. You are going to take action even on small complaint. Okay, that is what I meant by you are going to, you are going to raise the bar. Okay. So the key word for process map: identify all process input and outputs. Identify all. That's the key word. You don't argue about whether this only happened once in a lifetime. No. You identify. Identify first. Okay. Whether it happens or not, you can discuss. You can evaluate later on. First, you have to identify, like the wild animals. Okay. Sounds funny, right? Nowadays, you open your window and suddenly a big elephant was smiling at you. Funny, right? But it happens nowadays. Very frequent. It's not happen like once in a blue moon. No. Elephant appearing in front of your door is something that is not funny anymore today. Okay? So please identify all. Okay? Never mind, later on you can evaluate them. Okay? Okay? These are the categories that I mentioned earlier. Okay? The most important thing is to put everything on the table, meaning that to recognize everything, to put everything on the table for your evaluation. Okay, next we go into cause and effect matrix. There are 8 items that you need to be aware of cause and effect matrix. Number 1 is the inputs. The inputs must come from your process map. Okay, all the inputs that you have recognized in your process map. Okay, you have to identify them in your left column in the cause and effect matrix. Okay, of course in my template you have the process. Okay, in my template you have the process. Number 2, the outputs. Okay, on the third row from the top, you have the vertical outputs. You have to identify them in the third row from the top. Okay, and then number 3 will be importance to customer. These should be the inputs from your customer. How important are they to them? How important are the output to them? The receiver, okay, the customer from process number 1 will be the receiver. Okay, forget about the external customer first. Okay, because if it is important till the end of the process, they must know. They will tell you, no. This is very important. You cannot mess with this output variable. This is very important. They must know, because if it is not, the smallest, the slightest defect, it will become defect at the end of the process. Okay, customer definitely will reject. The inspector at the end of the process definitely will reject. Okay, they must know, and they must give you the input on the importance. Causal relationship strengths. Okay, you need to evaluate the causal relationship strength in between the input to the output. Okay, and then number 5 is the cross multiplication of causal strengths against importance. Okay, your evaluation here will be multiplied with the importance to customer. Okay, the importance to customer up there. Okay, on the top row. Okay, sorry, my pointer broke down. Tak boleh ya. Nasib baik dah habis. Okay. And then number 6, sort the score on descending order. Okay, you have the result, the outcome of the multiplication between the causal strengths against the importance to customer. Next, what you need to do is to sort the score. Okay, from the highest to the lowest. Okay, from the highest to the lowest, because you need to cut off. You cannot do everything. Okay, you need to cut off, and you need to determine the cut off threshold for the item you need to carry forward into FMEA. Pareto principle, 20-80, 20% of the input variable cause 80% of the defects. So you can cut off to 20%. Okay? Okay? So you can cut it off. Okay? And then number 8, carry forward higher strength cost relationship to FMEA. Okay? Next. Okay. The FMEA is for product, process, system during operation as well as design. Evaluate risk and problem solving. Okay, you can use this FMEA methodology or template for your even when the system or the product still at the blueprint stage. There's no prototype, there's no nothing yet, only planning. Okay. And in what ways input can go wrong? That was the biggest question. In what ways the input can go wrong? So that's why even if you look at control charts, what are the elements that you are controlling? Control chart, in your control chart, you ada belajar SPC? Ada amalkan control chart? SPC?
Tak ada.
Okay. Control chart, a little bit about control charts. Okay. Kalau saya punya program, SPC comes, control chart come together with POKIOK. Okay, in one program. So when you do your control charts, you do your control chart because you want to prevent occurrence of defect. Okay. So when you do a control chart, normally people do control chart because the process is still not stable, or suddenly the process create defects. You know, once the process create defect, you know, a huge amount of defects, then you cannot totally stop the process, but you need to put the process under review, under supervision, or under special attention. So when you put your process under special attention, definitely one of the things that you need to do is your control plan and your control charts. Why? Because once you put the process under control, all inputs need to have control chart. All your suspicious input need to be controlled. If you set the screw strength at 9, every single one need to be inspected. Then only you can build the chart. Okay, you need to stabilize the process first. Okay, by using that chart. For instance, another example, the Prius case. How can the robot in the Prius tell me that your car performance is not stable? Because the car keep analyzing the input. The battery level keep continuously being measured. Okay, by doing that kind of continuous diagnostic only, that the car can be guessed that the car will go into trouble in next few hundred kilometers. So this is the way, modern way of doing SPC. Everything is robotics, everything using AI, everything using computer. You're not going to measure it every time you need to get the data, right? So that is another good example of control process, control charts. So by controlling the level of battery output, maybe every minute, then you build the control charts using the data, then you can predict the trend is going like that or the trend is going like this. So they can predict that it's going to crash in just a matter of a few hundred kilometers. So that's why they can come up with that kind of preventive measures. Okay? Okay? So the question is, in what ways input can go wrong? You have to list them all and continue with the format. And then RPN is the severity times occurrence and detection. That is risk priority number. Okay. Without the RPN, severity multiplied with occurrence is the risk. Okay, is the risk, regardless of the detection, whether you can detect or you cannot detect. Severity multiplied with occurrence is the risk. that is the size of the risk that you are facing. Okay. And one more thing, any aspect scored 9 points automatically qualify the inputs for further analysis and countermeasure, regardless of the RPN. Even if the RPN is 40, severity is 10, you have to reduce the severity. Okay, you have to reduce the severity. Okay, any questions so far?
Score 9 means RPN.
Come again? Come again?
That one score 9 on the severity or RPN.
On any aspect of risk, on severity, on occurrence, on detection, in any of the three aspects of risk, if you have one input variable with a 9, then automatically you need to reduce the immediately automatically you need to reduce the risk. Okay, you need to reduce the risk. Say your severity is 9, macam tadi, kan? Tadi dia punya severity was 10, but the RPM was only 40. Was only 40. So you need to immediately reduce the 10. Okay? You need to immediately reduce the 10. You need to take actions to reduce the risk, whether it is severity, frequency, or detection. Okay? You need to continuously teruskan sampailah reduce to 8, 7, something like that. Okay?
If got 8, can ignore, can okay.
8 then okay. 8 and the RPN is less than 125. Okay? And then the RPN, the okay RPN is something that is less than 125. So you can, you can relax on the aspect. Okay? You can relax on the input. You can focus on every other things. Okay? You can relax on the input that is less than 125. Okay? Any other question? Please.
One quick question. For the occurrence, it says that the occurrence is based on the occurrence of the cause or the occurrence of the failure mode. For example, in our case for the change management, the wrong interpretation of drawing, for
Okay.
example. And then the cause can be competency issue, can be unclear information from the drawing itself, can be, for example, the job transfer between people to people is not good when people are quitting from a company. So each cause, the occurrence is different. Because job quitting is, the occurrence is very unlikely.
Okay.
So do we put the occurrence based on the failure mode or based on the cause? Because
Based on the failure mode.
based on the failure mode. But
The failure mode is a defect, right?
but in the template it says the occurrence of the cause of failure mode. So that's what I asked.
Okay. What is the Y and what is the X? What is the Y and what is the X? Y is the defect, X is the cause. Okay. Y is sure for you to know. Okay. Because you can see the symptom. Once it becomes a defect, then you still don't know the cause, but you know the symptom. You know that this is a defect. Okay. But you don't know the cause. The cause can be anything. Okay. So you need to base on the defect. The defect is the one that you can see, the one that you can measure, the one that you can count.
So the same story for defectability. So in the template it says how is it to detect the cause or failure mode? So but it is actually the failure mode that we want to detect.
Yes.
Because the cause itself is not clear.
The cause itself is not clear.
So later I will before this I will revise the template.
Okay. Okay. Any other question?
Not a question, just my opinion.
Okay.
But previously, normally FMEA will
explain to you. This is the different way of doing things. Okay. If you look at your 7QC tools, you have Ishikawa diagram, right? Okay. And if you look at your ISO 9000, the emphasis is on process. Okay. Process-oriented quality management system. That is the main difference between the two ways of doing things. I don't want to say that which one is better. To the Japanese, maybe 7QC tools is better. The specific process focus is better for them. But to people like us, we are not the Japanese. To the Americans, they are also like us. That's why they come up with the process-oriented quality management system, problem-solving system. Everything is process-oriented. They are not going. For instance, I'll explain to you so that you can understand. For instance, if you do your fishbone diagram is resource-oriented, right? Man, machine, material, mother nature, measurement system, right? Nothing to do with process, right? Method. But they are not going to evaluate process 1, process 2, process 3, process 4, right? Because in real practical way, the Japanese, when they designed this, when Ishikawa Sensei designed this tool, they were talking about solving a workplace problem at that specific site. Okay, what resources that goes into this task, this specific process? I don't want to talk about that process. I want to solve the problem that occurred here, only at this spot. So that's why they don't do this kind of comprehensive process 1, process 2, process 3, process 4 evaluation. They don't do that. They are focusing on that specific process. That is the Japanese way of doing things. The Japanese way of doing things is totally different compared to the American way. The masalah us, the way we do things. Okay, because Japanese are different people.